Good evening. Welcome back to AP Stats Notes Online. I only have a few minutes here that I want to talk to you about to wrap up Section 9.2, at which point we probably need to get to a quiz, but we'll talk about that more in class. So we're talking about these tests, and the basic idea behind a significance test is whatever statistic that you get from your sample, and right now we're talking about p-hats. So whatever p-hat you get from your sample, the real question is it likely to have gotten that p-hat assuming that the claim is true, assuming that the population p is really what the claim says it is? Is it likely to happen? If it is, then we're going to fail to reject H0. And if it's not very likely to happen, if the null is true, then we're going to reject H0. Okay, it's all about probability, and that's what our p-value basically tells us. Well, we can kind of make a tie between these significance tests and confidence intervals. So, can you use confidence intervals to decide between two hypotheses? And the answer to that question is yes, but it only works for two-sided tests. Okay? And so you have to sort of understand what it is that we're looking for out of a two-sided test. So let's say we're doing a two-sided test. We've gone through our conditions. We're assuming that the population proportion is p, that's true. We're assuming that's true. So if it is, our sampling distribution should have its center at p. Okay? Now, what we're looking for then is, let's say that we're testing out an alpha of, let's see, 0.05, okay? And we're doing a two-tailed test. That means that we're looking for some p-hat. So we're looking for some sample proportion, some p-hat that is far enough away from p that it starts to make me question whether we can still make this assumption about the population parameter. So we're looking for, I'm going to back this up. Let's make our alpha 0.1. Okay? So I'm looking for, out of a two-tailed test, I'm looking for a p-hat that is this far above our claim of p, or this far below. Remember that in a two-tailed test, right, our H0 is that p equals some value, and our alternative is that p does not equal. So we don't really care if it's higher or lower, if the true population parameter is higher or lower. We just want to know if it's different. So a p-hat this different, or this different, or more so, which is why we always shade above or below the p-hats, would give us that evidence, would give us a p-value that would make us reject H0. How is that tied to a confidence interval? Well, if you remember a confidence interval, what we do is we start at some point estimate, and then we create a margin of error that helps us capture all plausible values for p, right? These are all your plausible values for p. So we're assuming that p is true. That means that any of these values in here, any of these p-hat values in here, or any of these proportions in here are plausible values based on our statistic. Okay? Which means that if you were to obtain any of these values in your sample, then you wouldn't really, that would indicate that the population parameter is what it should be, right? If we create the confidence interval starting right here, then the interval is going to capture p, and so the p is a plausible value. There's a lot of different ways to look at this, but these are all acceptable values from a sample that wouldn't make us question whether or not p actually is what the claim is. Okay? These are your plausible values. Now, with your interval, if these are plausible values, that means that these are values out here that are not plausible, which means that if P is true, then it would not be likely for us to get a P hat out here or a P hat out here, which is why we would reject the null. If our P hat is a non-plausible value, assuming that P is true, then we'd have to reject H naught. Okay? So since confidence intervals give us plausible values for the population parameter, and we're trying to find values that are not plausible, assuming that P is true, that's the connection between intervals and two-tailed tests. Now, why is there not a connection to one-tailed tests? Well, because if you try to do that, right, where we assume that P is true here, okay, it takes this P hat to reject it, right, then we'd have to create an interval of plausible values that starts there and runs all the way out here. Okay, and intervals don't do that. At least not the intervals that we're going to talk about and the ones that we're going to construct. Okay, so there's not a connection to one-tailed tests. But there is this connection to two-tailed tests. And that's the connection. In an interval, we're getting plausible values that might be our population parameter, our population proportion. So any value that falls outside of that is not likely to occur. And so it's the same thing here. In a test, any P hat value that sits out here or down here are not likely to occur if P is assumed to be true, if the null is assumed to be true. So there's that link. Now, the additional link is if we're looking at an alpha of 10%, then our P value, when you combine this area and this area, would have to be 10% or lower. So we're talking about this area being 5%, this area being 5%. And so the confidence interval that would be linked to an alpha of 10% would be 90%, because that leaves 90% to be in the middle. Okay? So the link here is a 90% confidence interval is tied to a 10% alpha. And you could do this also. If our significance level was 0.05, then our 95% confidence interval would be linked to it, because we'd have 2.5% in these two tails, and that would be the link there. Okay? So confidence intervals can be used to decide between two hypotheses also. If we construct a confidence interval and our P hat falls in that confidence interval, then it's not going to be a strong evidence against the null, but if it falls outside of that confidence interval, then it would be strong evidence against the null, is the bottom line there. Okay? So I'm going to get rid of this so we can see what's underneath the blue screen, but hopefully that helps in making that tie. Okay? Now, what is an advantage to using confidence intervals for this purpose? Well, not only will it help us reject or fail to reject H naught, but if we do reject the null, it actually gives us a set of plausible values. So it gives us more info than a significance test. A significance test just says, you know what? Based on this P hat, we're going to reject H naught. It doesn't say, well, we're going to reject H naught, and here's what I think the population parameter actually is. Okay, and so that's what a confidence interval does. It gives us some idea of what the population proportion might be. And here's how that works, right? We were using the idea of a normal curve before, and I'll go back to using that idea now, assuming I can get a Moby board that works. Here we go. So again, the idea behind a test is, all right, we're going to claim that P sits here. There is a P hat that is as different from the claim, or that is different enough from the claim, that would make me reject the idea of the null hypothesis, right? And so again, the null would say that P equals some value, and the alternative would say that P does not equal that value. So P hats out here, or even P hats out here, would make me reject the idea or suggest that P is not the population parameter. So if we come up with a P hat out here, then we're going to reject H naught, and we're going to say, okay, population parameter is not P. A confidence interval goes one step further. It answers the question, okay, if it's not P, then what could it be? What's it plausibly to be? So what we would do is we construct a confidence interval about P hat. And so when we did that, we would construct an interval that did not capture P. It would stop short of P. Because obviously if P was in the interval, it would be a plausible value for the population parameter, and we wouldn't be rejecting it. Right? So what a confidence interval does is say, okay, well, P, if we don't think P is the population parameter, then any of these values in here that are plausible values could be. It gives us an idea of what P might be, right? So the bottom line is if P is in the interval, then we're going to fail to reject. If it's out of the interval, then we're going to reject H naught, and a confidence interval would let us know what P is most likely to be, right? So, and again, we made the connection already between an alpha of 0.10 being linked to a confidence interval at 90%, right? We did that using the probabilities and the tails. Okay? So it does give us some indication as to what the population parameter might be. Right? Now, the link isn't perfect. And I just erased all this. I can bring it back, actually. The link isn't perfect. Because if you remember that when we calculate the standard deviation for this normal curve, so your standard deviation of your statistic is going to come from using the claim of P, whereas the standard deviation of the confidence interval didn't have a claim to P to use, and so we used P hat. And we know that P hat is likely to be different than P. So the standard deviations are a little bit different. So the link isn't perfect, isn't 100% solid, but it's close. And it's close enough that having this tie between a test and a confidence interval makes enough sense to talk about. Okay? So, bottom line, if P is in your interval, then we would not be rejecting H naught. We would fail to reject H naught. If P is outside of your interval, then we would have to reject it because we don't think it's a plausible value. All right? Now, that being said, if that's the case, if confidence intervals give us more information, not only will it help us reject or fail to reject H naught, but it would give us an idea of what P most likely is, but I don't use it all the time. And what I was just talking about before is that we're not limited to two-sided tests. Sometimes we perform one-sided tests, and when we perform one-sided tests, we do not have, at least not at the AP curriculum and basic statistics level, do we have a confidence interval that it has the same strong link to a one-sided test as there is for a two-sided test. So don't get me wrong, there are confidence intervals that are linked to one-sided tests, but it's far beyond the scope of what we want to talk about. So for right now, why don't we always use confidence intervals? Because we don't always have a two-sided test. Which is also important to understand that if you come across a problem on the AP exam and asks you for sufficient evidence to reject a claim, it is perfectly reasonable to construct a confidence interval to do that as opposed to performing a test, a significance test. Now, if it specifically asks you to perform a test to make that decision, then you're sort of stuck doing the test. But if you like confidence intervals and they make enough sense and you know how to use them, it would be a very plausible way to support your decision on whether you reject or fail to reject that claim. Okay? All right, that's it for 9-2. We can start working towards a quiz and start talking about that in the next class period. Enjoy your night. Homework should be in the text, and we'll see you guys next class period.